Okay, well, let me get started here. We've been supporting MTConnect for many years with the dream of having everything connected. And unlike most people, we wanted to have every machine connected, and we called it years ago the Factory Automation Initiative. But I wanted to talk today about one little thing that we're doing, which enables legacy machine support. But I'm also going to give an overview of all those ways that you can collect data, because a smart edge device is sort of the key to this. So here's what I was going to talk about today. My background and our background here at Nexus, talk about this issue of legacy machine support for MTConnect. So why do we need it? How can this be done? Go into depth on organic blueprint, which also applies, of course, to other machines that it can serially output, gas costs, etc. And then some data gathering options, a demo, and then some questions. I always like demos, but hopefully with the machines in the back, it won't be add to the proof of concept. So a little bit about our background. I founded Memex years ago, and in that capacity, we did a lot of work with the XML. So I've been involved in the CNC memory upgrade business, in the DNC business, and MDC business, Linux adapters, battery replacements, IO tapping, FMS design, retrofits, quite a few pieces. What's unique about us, and you can see this from the variety of products, is that we're dedicated to the success of our customers. So whatever it takes, hardware or software, to make it work. And it's also led to a lot of interest in research, working with different universities and various companies over the years. It also gives us a unique perspective. Many years ago, we got approached by Siemens, and this graphic came from them and their EPS group. They wanted to connect externally to all the machines that they made, the Siemens controllers. But we pointed out to the folks that there would be always a problem with people poking a hole through the firewall for Siemens to gain access. And so we promoted the idea, saying that it would be great if an independent third party could manage that safely. So at the time, I took my company and we made it into a public company in manufacturing networks. We got Greco systems to get on the protocols, we got multi-DNC, we've got IAS to get fully certified code, and really took it to the moon, and that caught Siemens' attention to the point where they offered to buy us. Anyway, the idea here was that about 7 million plus machines are out there, but very few of them. I said a max of 25%, but it might be lower, that have MTConnect as an option. So we really have to think about legacy machine support. So I've also thought about security. And so we've got a quantum resilient encryption algorithm that we're blending into this. And so it's going through its paces right now from the CMS ITAR side of it. But we've been focusing on the last bit of connectivity to every machine. And that is kind of unique, because most people are relying on the machine builder, but the machine builder doesn't have the engineers from 20 years ago to make that happen, or they don't want to buy a new machine, is sort of the idea. Also, we want, because of our unique background with MTConnect and the OMAC XML schema before that, we would like to see if anybody, all machines talk MTConnect. So somebody's got to join that bridge that gap. The other part, of course, is security. And so we've been looking at algorithms, reducing waste, reducing carbon footprint, MLO monitoring that John's talked about, legacy machine protocols, various other things. Whatever we can do to make it happen. On the right-hand side, you see the idea of a hardware abstraction layer. that talks to an ERP or an MES layer that can talk to a cloud layer. Now, what's kind of unique about this is that most of the time the data goes up, especially in a read type of protocol. We wanted it to go up and down and to have smarts and algorithm right at the machine level, so that we have a massively parallel architecture so that we can handle 7 million machines that are flowing up the internet. So it's a much more ambitious goal for MTConnect, and so we call it the metadata stack. We've put together, and some of the members of the team are actually on this call, over the past years, a bunch of Linux device that is doing a lot of this work for us with the MTConnect and various other DNC machine monitoring, vision systems, all kinds of stuff built in. And it really is, it addresses the central problem in our industry, which is closed hardware and software architectures. So you couldn't get there from here. And how I relate this to people, and Tom Copeland, you sort of said, how do you talk to normal people about this stuff? And I said, well, I want to turn the machine into a metal printer. In other words, the real smarts, the future interface, all the things you wished you wanted on the machine, no matter how old or new, go through a bolt-on coprocessor that does all the work for it. And this is huge because if we can get a universal low-cost add-on to all these machines, we've got a new Cisco to factory floor, a new standard. So lately, we've been doing a lot of work with Accelerant for MTConnect and front-end graphics, but theoretically, this could work on anybody's. Anybody who takes MTConnect can use generic box. People like Haas were interested in putting it on, 1,500 machines a month, or Dr. Mori with those place like Sacramento, or anyway, there's a lot of OEMs that are interested because they want somebody else to keep current, and they want to be able to offer this as a solution. It's web-centric, so it generates a web page instead of that client. Nice thing about that with Google is you can do language translations and that be a world player. And of course, this could be opened up for APIs and other people who do stuff. We did put for a group called chip-based that does MRO tracking and Docker implementations where they could manage their own software. Anyway, we've got our own VPN, we've got our own various other things to manage these things worldwide. So just to show you what we're doing. I wanted to get into what we're doing with dprint. We've got some of test stands and various other test stands here in the lab up in Hamilton, Ontario, Canada. And a lot of people have the ability to leverage something simple. And the idea of having a end user tool that can convert to MTConnect was something that just seemed natural. Now, what's unique about this is that a lot of times people in the machine data collection world focused on parts count. How many parts am I making? If you can track that, you see what effectiveness of the numbers, et cetera. Jan brought up the case of, that's great that I know how many you made, but I don't have the story behind it. If we made more or less in a day, what happened? Or what about the operator being able to color the data? And that led to an interesting part of, hey, why don't we leverage something that's built into a lot of controls, this dprint command, serial dprint, and watch it. But then the question was, well, it's heavy lifting to hard code that in. So one of the gentlemen on the call, Kevin Cousins, he came up with the idea, why don't we make a generic formulaic-based system where the operator can send us a code and we'll convert it to MTConnect, and we don't have to know what they can do or not do or how they want it. They can do the whole thing themselves. So in other words, it's a generic toolkit, dprint and any other input mechanism into MTConnect. And so I think it's actually really a brilliant idea here, because this means less coding, less heavy lifting, less customization, and more of a toolkit that anybody can use. So if your package can support, tooling information or whatever it is, but maybe, great, you can code it in if you want it. And if you want something simple, is it on, is it off, how many parts it made, you can do it. see on the left here, this is a part program that I made up that I'm going to run, actually. And we created these commands. Actually, interestingly, the exset command is our new extended command. It was something that Accelerant, our friends in Connecticut, had come up with for parts count, and we just extended it to handle all the MTConnect stuff that would work in the mechanic world. So anyway, what happened here was that so we used some custom macros, some M codes, you see 127, 128 for parts count, and MTConnect will sense what the count is and what the difference is. And then we've gone through some very interesting places in the last little while, especially with screw machine services, where we have continuous cycle and 99 type stuff. So we had to come up with some creative ways of monitoring it and giving parts count. And we also had interesting parts count with multipliers and with pallet systems. So you have to have a generic, you have to have a way to handle all the different ways that people will make stuff, let alone using codes for scrap and other things. So the idea was if we could have a generic box down at the machine that could take some of this data and run it. We also, in the, and I'll show you the product a bit more in a second, have the ability to auto-insert these commands so that you don't have to change thousands of our programs. So as you're uploading the file, if you want it, we can insert the appropriate PO pins and D prints, et cetera, say to track MOOs, to track the part number, to track the breakpoint in the file, to track what, the end of the file. So it's kind of a very flexible way of dealing with legacy machines. And there's a bunch of customers that have old zeros, it's 400,000 of those, 21, various other ones that didn't have very many options, no focus, let alone 10, 11, 12s, or even 6s with macro A and B. B print and B print are macro B features. Anyway, so our system is sitting on, it can be either a network connection, wireless, and a connection to like a bridge device serially. So what we do is we basically have a serial port open all the time, and we're picking up these commands as they get executed by the machine. Yes, it takes a little bit of cycle time, but the benefit here is that you have control over it, and you're timing it and putting all the pieces, and you can add or delete them depending on what it is. So this, I think, will be much more flexible for people to make their legacy machines MTConnect compliant. This is an example of the data coming out. This is just a Telnet, PuTTY connection to 7878 from an MTConnect adapter that we're generating from the OP unit or the Orion production interface. The top one there is sort of the boot on, tell us what the current state is, including the serial number of the OP and other things. And then the second one is what happens as it goes through. And unlike other commands, it sort of parses and only gives them what it is in real time, which is, and you've got debug and tracking capabilities that you can watch this while it's talking to your external application. So this is nice if you screwed up the command. You might notice that some of the MTConnect commands have underscores, which are not allowed in FANUC world. So we've taken the minus or hyphen and translated that to an underscore so that it can be compliant. So once again, it's relatively easy. So the beauty with this is that if you have an application that supports MTConnect, you can go nuts with this. You just get one of these units and start making these deep print commands, and whatever you can do, you can get. And so this is actually very useful. Our friends over at Accelerant, I've been helping them from a direction point of view. They've got a wonderful interface, web-based, SQL backend, etc., And they're one of several, many companies that have ways of doing this. But what was nice is that I had an internal view of how we could make this work. So they've got DNC and MDC, and by the way, DLB that supports DNC and FFD and all the usual protocols. Very interesting, but you can see it in real time. People love, as Tom Copeland previously said, to see dashboards and to run their shop in a visual manufacturing. So when you see it change color, you know what's going on and it tracks it. That data underneath becomes this data that you can drill down. So now you see the actual tags coming in and showing up on what I call the big board, and how long it's been running, how many parts it's made, whether it's a feed hole, whether e-stop was on, whatever it is that you care about, what the part program was, and it can give some OEE data, et cetera. So I'm just showing what you can do once you have the data. As I say, there's many good pieces of software out there. I just needed something to demo this in real time. So what we're doing is we're working on data-driven manufacturing. So the machines become network appliances on the factory floor. It's a generic solution. You don't have to have custom for everything. We support, the beauty of a platform play like this, as opposed to, say, some dedicated boxes like Moxa or any of the other guys, is that we can keep on adding to our heart's content. And we've got 16 gig SD card in there. And, we could put as, all the part programs of everything that they need. We can put images. We have a camera system. We've been doing some augmented reality with the Concordia University. And I gave a presentation at the FAIM conference last year about this. We've done, we've got Wi-Fi and we've got gigabit Ethernet for rapid deployment, and it supports protocols and various other things. So you'll see on the bottom left is a screen that came out of the plant, and this is once again an accelerant screen, but you can see the huge amount of detail that you can get, and you can slice it and dice it any way you want. Our job is to get the real-time data. That's our job. How it's presented, what people like, operator logging in, et cetera. You can do all of that and then show it. On the right side, you'll see our implementation on a Star screw machine with a 16 TV control. And you'll see that it says Nexus OP5, and right underneath it is a little box, and that is a unique box. And there was a picture of it earlier. It's called the family. And what it does is it monitors the I/O link bus and grabs 1,000 pieces of data with zero bandwidth from the FANUC control. The FANUC control, the entire FANUC control goes through our device, but it never knows it, and we can track all the information, every key press, every light that goes on. And if we ever got further with this, we could do much more with it. Servo drive monitoring, you can do anything you want. And we've done some of these projects when we did the Mazak FMS retrofit. And we learned what to watch out for, what to do, and how to do it. But this one is very interesting. Now this is IO Link 1, there's IO Link 2, and it's in, from the I series up that has this. But it means that in about 10 minutes you can grab, tons of data, just go plug and play. So it's very innovative. I wanted to also, in order of something I think would be useful at this point, is to talk about all the ways that we have gathered data from the machines. And I'm sure that everybody sort of knows this, but very rarely do you get one company that is invested in all of these. And we're trying to be, the Cisco of the factory floor and have a little niche that will promote MTConnect and really make it fly forward. So the first one we do is network protocols. So anything that can grab Jim Brown from the keynote, talk to us about the MTConnect, the focused MTConnect, and if you see, they did make their own little device in the end. But if we could make everything MTConnect, it would be great. But there are some network protocols, and we have a focused bypass in our system where where we can have people go through us and we'll bridge it into the controller. For instance, we work with Zoller in the tool presetting world with this. And of course, MTConnect. So we're kind of excited because now a whole pile of more machines can be MTConnect compatible just by getting this device. The second one we do are serial protocols. As you know, and this is where the deprint discussion today comes in, but there's a lot of protocols. One of the reasons that I bought Greco was to get access to 1,200 protocols because I don't have time to figure them out myself. You know, the LSV2 and QData for Haas. And anyway, there's a lot of different ways of communicating to machines. Our goal is to sanitize those, not only for the DNC component, but more specifically for the machine monitoring component. Because there was a realization years ago that, especially, you know, because we used to make BTRs, with tape readers, and the realization is we are the control. The last thing that the system sees is our code. So if we started tracking what we were sending it, I could do tool-like management, I could do anything I wanted, because it's going to do all. And we actually proved this with a robot integration with System 3R. And then I filed a patent on it called dynamic computer-aided machining. And that's another story. Anyway, continuing with this list is operator input. So tablets, operator portals, barcode readers, you know, information from ERP and MES systems, et cetera. There is a need for the operator to be able to color the data. And that's something that our research has indicated this helps with change management and adoption. Because, you know, somebody will say, you know, big brother, I'm watching you. Like years ago down at Solar Turbines in San Diego, you know, we had too much data and we're blowing up the fiber optic lines. So that was one of the mistakes. We have to be very cautious with how much data we pour out. And the second one at Contour Aerospace was that we put cameras up and the workers put rags on them because they thought it was Big Brother. And so this is like, you know, 20 years ago. So what we had to do was we had to be very specific and say, no, all our research and vision systems is designed to garner data about the machines, not about the people. And so putting it in the work envelope is good, but sometimes you can't do that. So we had to be very careful with it. The fourth level of gathering data is virtual I/O. The fan link that I talked about, the I/O link, monitoring, that is a huge new area. I mean, we can take any CNC machine and basically get on its bus and figure out what's going on. It's just that it's a lot of work, you know. And you know, maybe with the Canuck Zero with 400,000 of them, that makes sense. And we've actually done that. We've got onto the bus and done backup systems using the engineering panel port and the order made macro port. But needless to say, that's a lot of engineering. But you can make a product that you can mass produce, and now, you know, 100,000 people can have MTConnect for no cost. You know, just plug it in and go. The other one we've been playing with is power monitoring. We worked with the Master Manufacturing Research Institute and some of their master's and PhD students, Professor Yamazaki at TrueCNC up at UC Davis. There's a variety of people that have been interested in this area. Wonderware down in Orange County. And it's spun off groups like Freepoint and various other people that, you know, yes, we can monitor the power, but, you know, we're trying to build it into a much larger system. And one of the reasons for our high-powered quad-core 64-bit with 6 GPUs, OP unit or OP4 at the time was that we could do the real-time calculation right at the machine for this type of filtering. And we realized that in doing some research, and UBC has done some interesting research in this, that it's a huge exercise to gather data about the machine by its power usage, but it is the common denominator of all machines. So it's a future research project. We can do basic stuff, you know, as the symbol on or not with just slapping on a Hall effect sensor. But we don't have the other piece of it, which is the real-time data. You know, I see a tool change by the signature. So it's an interesting one to go after. Then the traditional way of gathering I/O data, you know, hard data, you know, 24-volt I/O, or if you're a Haas or you want to be different, 12-volt, you know, and grabbing the basic signals off the contactors. Heavy lifting, difficult to do, error prone, and you better, right now we have a rough time finding installers. So yes, we've got 50 dealers to handle it, but I don't trust them to necessarily know how to do it and do it perfectly every time, because, you know, we got to come up with an easier way, more plug and play. But there are some extremely good, you know, very confident service techs that no problem will rig it up. But one of our goals is to create the master database of how to connect and gather data from MTConnect on every machine ever made. So we've got some mega goals here. We even spun off a project doing called Sensei, where we did augmented reality with the cell phones and voice and putting basically sensing what it was looking at and then having next to it at the other end. Anyway, we've also pioneered an idea called I/O tapping, which is a very easy way for us to grab data. So people that do robot integrations or monitoring, they sort of buy our little products that make grabbing data off of the machine easy. And then the last one, the one that's going to be a lot of fun in the future, vision systems, augmented reality and AI. And I see a huge future in that. So we've done development. We're at the university stage doing that, and I'm very excited. But those are the 6 ways that we can get the data but last put in every machine. I was going to give a demo, so hopefully this will work. And just because people like to see things actually move, and what I'm going to do is I will start in on. So we've got a. I'm going to turn on the control. Maybe I should. I don't know if I can show myself and the screen at the same time. Let's see if that works. So, okay. So what I'm showing here is some basic information. This is the accelerant page. We've got some DNC and capabilities. So the one I'm on right now actually is this one. So you've got MDC, you've got DNC, you've got protocols, we've got SMB, we've got various ways that we can talk, including so we'll do a quick correction there and then get it back online. This is what the X means, is that it's not connecting, probably because I have it locked. So we can do file requests, we can do naming conventions, send and receive patterns, you know, the usual suspects for DNC. It is interesting. There's a lot of ways you can connect. Mori, SMB, FTP, Focus, OPC, that you can connect with this. So we support all of those things that John Carpenter does in this package. So we got rid of the X, so we're actually connected. And there's a lot of functionality in here. I'm not going to get into it right now because it's not the purpose, but I wanted to show the pieces running. On the machine. So, yeah, there's a lot of data. I was running it as a test case bringing over a link to it, and needless to say, I've been sort of running that test file over and over again. And I'm going to, let me just see if I can show my camera so you can see the IMA. It'll show it. But, so we've got, let's see how many different ways I can play the screen. This way. And we'll open up a different browser so we can see something else. Anyway, the idea behind it is that we've got the I want to see it as big as possible. All started running. So I just booted it up and put it in that mode and then I can start. And hopefully this will show things happening. It's figuring out we'll get a second browser. I have 5 monitors, so I'm not used to using one monitor anymore. Well, I can flip between it if it's going to take too long. Anyway, the idea behind it is that it's now running, it's green. So we'll, and you'll see that with the MTConnect command that came out. In fact, I'm in feed hold. I just gave it a feed hold. And now it's done its productive idle. And now it's going to, basically it's running a cycle of what's happening. So this is all being populated into a SQL database. Change the resolution here. So here's the live data coming in. There is a little bit of a delay, like 2 seconds as it goes with the but so I've rigged up a macro so that I can change the name of the file, so it's like my counter of how things are going. And you will also see that it comes into the serially into the device, and so we can drip feed. We can, and we've actually done an innovation where while it's drip feeding, it can also pump out MTConnect commands. So this is a very interesting. Here is the commands coming out now. So they're coming out serially. We're repackaging them in MTConnect, and it's going up to the application that can show it. And so this is, you can send and receive files. You can do map drives to a network server or back from it. There's a lot of configuration options that are available just to show different things, the usual stuff that is needed. It supports remote directories, and sockets, and FTP. And here's where the MTConnect is enabled. So you idea is a generic, and then this one, transmit the dprint messages or not. Sometimes you don't want to have things go out. And then we've got a sed command so that we can do auto insertion of the dprint commands, so that while it's sending the file to the machine, it can add the dprint. So these are examples of you can connect wirelessly, you can have a UNC host name, it supports DHCP beautifully, you don't have to have static IPs, there's no custom software that has to be mounted like Moxa. It's got its own embedded ports with 15,000 volt DSP protection on it. It supports 7 to 30 volts power. So it's magnetic mount, so it's really designed, and even the help is on the box itself. How to use it, remote calls, web pages, USB if you want it inbound. How to set up. One that most people have not used a lot is M198, where we found that to be extremely useful. It just obsoletes all memory upgrade issues. And the beauty is every time the file is sent, we can use MTConnect to track it. So it's very useful. Okay. And then I think, so there's a lot of pieces of this puzzle. I'm sorry for going quickly. I guess I have a bit of time here. But, I wanted to show you it actually working, because a lot of time and effort has been spent on trying to get this to a point where end users could install it easily, or OEMs could put it with their machines. So last couple slides here before we get into a question period. This was the heart of the dynamic computer aided machining path. And the idea was that whoever controls the G code controls the machine. And so this is, every time I realized that we could do many things with the data coming out, and we could augment every machine ever made with some optimization, this is the beginning of something. So when a customer gets machine data collection, they also might get reduced cycle time. They might get better surface finish. They might get, we have a camera system that does onboard coordinate measuring machine and quality tracking. We've got, we can read barcodes or QR codes. We can see the orientation. We can tell a broken tool. We can double check the tooling by watching it, that it's the right tool. This is going to change everything, and it's all based really on MTConnect being a universal engine, because we can't possibly write all the software to make this happen, but we can grab the data, and a third party could say, hey, I'll take that tool like management and run it for you, remotely or on-prem or wherever. Or, hey, we could, write something for, code conversion or scaling or whatever it is that people need. And this is pretty interesting. I think it could really advance the art of manufacturing. Robot integration, I integrated a robot in 4 hours using this model. 4 hours. In fact, it was a challenge from the local machine builders association. And I said, okay, we've got a model that makes it easy. And so this brings automation and forward. So we get IT. Obviously, we're programmers that wrap hardware around our software, but we get it once, get it right, get it digitally, get it to everyone in real time. Do you have any questions?
Yeah, Tom, do you have a connection manager of some kind built in that either the admins or the user can actually access?
Yeah, it's got a. You mean for third-party stuff, or for just
what brought it up was you were talking about, one of your slides had 6 different methods of connectivity.
Mhm.
And it's something that historically not a lot of customers were asking for, but over the last couple of years, I saw a lot more people that want to have that sort of like meta tools to understand this is my MTConnect agent, this is an OPC server, and actually intentionally having blended installs, and then also having the, I guess, meta tools to manage those connections themselves in some cases, and sometimes just for visibility on their side.
Well, the beauty with this is that we've got a bunch of Linux running underneath it. We have unlimited potential to add pieces and portals, and like I said, with Docker and various other things. There's a lot that we can do. We're opening up I mean, people will buy it to have a wireless DNC system, and then they sit back and go, gee, I'd like to do machine monitoring, which we can do easily. Or, hey, I'd like to have a connection to my network-based controller and do a file sharing, and we can do that easily. Or, hey, can you guys watch the data going back and forth and tell us what's going on? Can you leverage one of the simple, protocols like Ethernet and make it into MTConnect? So the short answer is yes, because we broke the central problem in our industry, which is closed hardware and software architectures. And the moment that you break that, the world's your oyster. Now the question is, there's only, handful of people working on this right now. So, it's a tool, right? And we have a unique MTConnect tool that allows for tens of thousands, hundreds of thousands, or millions of machines to be connected with MTConnect. This changes the dynamics and the business structure for everybody on this call. If everybody can get it easily by plugging it in, or if it becomes like Gene Haas wanted, give me 1,500 of these units a month and I can say I'm MTConnect compatible. Oh, and you can do the legacy machines? Fantastic. And, let alone Cheryl Morey at P&G Morey or any of the other folks. So this is, I think MTConnect could move forward very quickly. And this little thing that we're showing, this deprint MTConnect, is the engine that could be replicated for any of the protocols like QData, even Focus. That's what Jim Brown did in the keynote. But we need something that is generic, and it could be made secure, and it could be made to work inside people's environments. In fact, we're even encrypting the part program data and the MTConnect data, and Will and I have talked about this because we've got people like Lockheed Martin that would love to standardize on this on all their plants all around the world. They just want to have the world's best security. So I didn't show that, but our work with Terra Nova Defense and our quantum resilient encryption algorithm, we have a powerful enough device here, and we're going to embed it. Now, that's a very narrow little market, but we do have already a open VPN link back up to our central cloud servers, and we're monitoring all these devices. And we make it for the European Union so that you can turn it off. So it can be default on or default off, and turned on when the customer needs remote tech support. And this is how we handle stuff around the world, Singapore, GE, or Australia, or Switzerland, or Italy. And, so we're kind of obsoleting the memory upgrade business. We're obsoleting the DNC business. We're obsoleting and the beauty with this is that you can upgrade. So if we get new versions of MTConnect, we can just do patches. So it will be our responsibility to keep people current with the latest and greatest, which has been a big problem. And that's why we have such an issue talking to people's software. It's all over the map. I've had to link to 1.3 and, up to 1.8 just with one vendor. They had it mixed and matched. It was a real pain. So that element is going to be kind of mission critical. But our job is to get the data, and then we can give it to the world. And then a whole pile of people can take it from there. our hope.
Hi, Tom. This is Andy Dujensky with Georgia Tech. How are you?
Good, Andy.
Great. Hey, kind of a follow-on question to Russ's about a connection manager. Um, we've used Node-RED with good success. It's a low-code application, and you can spin it up quickly and various other advantages. It can also be easily upgraded by just people write new nodes where there's currently OPC UA nodes, there's serial nodes, file nodes, all kinds of different nodes. And maybe this is a question for everybody, since it's no cost, open source. One thought was if people would develop nodes for Node-RED that handles the connection to machines or sensors or whatever, then a lot of the work is done as far as the application goes, and transfer data from a machine out to whatever protocol or database you want out the other direction. What are your thoughts about that?
Well, I think that if we want to move quickly, we're going to have to get more people helping apply it to the world. And we've looked at some of this already. I just asked one of our developers who's online here if he wanted to answer it, but the idea is that I think we are onto something and that we can easily port in. We have all kinds of horsepower and we have all kinds of memory, and we've solved some of the problems inherent with embedded systems. We've been doing this for a while. Ironically, Tom, one of the oldest machines running our unit is a Prototrack. Like 7 years, continuous 24 hours a day running. And so it's, we've found all kinds of issues with connecting to machines. Heat buildup, power fluctuations, serial ports that are a bit weird, protocols, people changing stuff, etc. But the connection to the outside world and the ability to write, to have other people helping out with nodes, APIs, make sure that we can't screw things up at root level, and harden it up, means that it becomes a platform for the future. I mean, we're writing it it's easy to do for us to bend in some of these things. Like we did a Node.js version, we did a JSON interpreter, we did of course, HTML and other things. And, we've been reluctant to put databases into it, like Mongo, because we are trying to make a hardened system that can withstand being shut off and not corrupting. So that's one of the issues. Now, that said, we've got some new battery backup technology that we're using for FANUC CNC machines. In fact, the first user of it is Rolls-Royce jet engine in Indianapolis, and they've got 1,000 machines. So this could easily we can engineer a solution to have more and more, as I said, a massively parallel environment. So Node-RED, the latest and greatest of what MTConnect has to offer, the integration into, for robots and various other things. I mean, our way of looking at the world is we are the CNC. You don't talk to the CNC unless you go through us. So it makes it so much easier for integration of third party, like the LMS and the bar feeders, the pallet systems, the tooling systems, the Renishaw Touch Pro Systems, M&H, Marpos, like it goes on and on, of all the people that wish that they had a better interface into the machines and what they could do with that data. So how we do it, we're open to suggestions as the technology keeps on changing, but we're one of the few people that have the ability to just say, no, we can just add that, no problem. Right, as opposed to hard coding it. So we are very interested in partners because it's time to, you know, triple the number of MTConnect users every year. And there's very few people that can do that. But if they get DNC and they get machine monitoring and they get quality systems and they get production systems and they get optimization and they get lights out manufacturing and they get vision systems and they get traceability and they get dynamic tool life management, G10 type stuff, why would they say no? Even if you just took one or two of those. Anyway, we're having fun.
Andy, Node-RED has come up a lot of times. I would say the summary from what I've talked to people about it is, you know, if you're not a developer but you interact with a lot of equipment, it's a godsend. And having visual flows is fantastic. If you are a developer, particularly if you have extensive experience, maybe not in the OT space, it's less helpful. The good part of it is existing nodes that already are out there published by others. The not as good part is just general developer derision towards visual flow based systems. So I think that a combination of like both together, Node-RED and kind of the underlying technology, not just the visual flow based editor. I think both of those bring more people to the party, as Tom alluded to.
Well, that's the next big thing, is that we have to get more people into the party. So the OEMs, yes, the integrators, service people, and you're right. We fight the IT world a lot, and sometimes we, you know, the IT folks are clamping it down, and we have to play in that sandbox. But luckily, this idea of remote support, my vision is that we have, you know, teams of people that can remotely put these pieces together. I mean, Amper, for instance, came up with a way around it. They just put a GSM modem in and said, we'll monitor it and bypass your whole IT group. Well, yes, we could do that too, but I don't know if I really want to do it that way. Maybe it's a backup. We also did some work on a satellite feed so that our customers would talk. We called it orbital computing. And there was some traction with that, and, you know, people that are not part of the internet. So for the ultimate in security. So there's some very interesting pieces, but at 1.7 million for a portable thing used in disasters, at least we have access to the technology for the sky. So there's some really cool things out there that you can do once you wrestle that data out of the machine, like preventative maintenance, like predictive maintenance. That's another big one. Especially if we don't have enough people to run the machines, we've got to get smarter, and we have to do it fast. And the other last one I'll leave you with, which we talked about at IMTS, is we have to start memorializing all the information that runs our world, because people are retiring, people are dying off. All the ways of fixing machines, running machines, optimizing them, they're all, so you know, there's not as many young people to do it, and it's not always written down well, and so we have to memorialize that. So we've started an idea of preventative maintenance for all the EEPROMs that are going to start dying, you know, on these machines. It's spent a long time on a Warner and Swayze vertical turret lathe and did something that Panic couldn't do. We built a Pascal ladder, and that was a royal pain. And that machine is nothing without its EEPROMs and its PMC cassette. So there's a digital preventative maintenance. You heard it here first. It's going to become huge. So let's wrap technology around these aging machines. Let's turn them into metal printers, and let's use MTConnect and anything else to connect them and optimize them and turn these disparate machines into one big machine. And there was an article for us in 1998 in Modern Machine Shop about us doing just that. It was called Shop Floor Nervous System. So you can go back to 1998 and see where we came up with this. It's been fun.
I'm gonna come to you when it's time to write the history, the second brief history of digital machine.
Yeah, I was the guy that told, you know, when the MTConnect book came out, I'm like, wait a second. Wasn't I the guy who flew down and talked to you, Dave, about this? I'm the guy that got him interested in the whole thing. I flew down to see him and said, dude, the network is the future of manufacturing. Because he was at Sun at the time. So
Thanks, Tom. Thanks for presenting so much, and thanks to Tom Copeland and the other presenters this morning. If you missed this morning, all the sessions will be recorded and posted later. I don't have a spot for them yet, but I will follow up with everybody who attended via email. If you're on the standards committee, they'll be posted to the project's website. Were there any other questions for TomGaasenbeek before we wrap up?
I just have
Hey,
a really
Tom Copeland, what year was that Prototrack?
very early, it was hard fitting our box in. 20-year-old Prototrack.
Okay.
And still had serial. I can send you a picture of it if you want. It was a fun one to get into. But the point is that we could, it still had serial communication. And it's online as we speak. So the ancient ones. But thank you for the opportunity, Russ, to speak, and for everybody listening. We're up to something, and we can't do it alone. So we're open for partnering. We're open to have things work. We like working with schools, Andy. We like working with projects, and we like solving tough problems. So we're the Xerox PARC of our group. I founded Memex, I founded Asterix, I founded eManufacturing. You know, but I retired, but not for very long. I couldn't help myself. That's where Nexus came from, where everything comes together.
Andy, did you have another question?
Yeah, just excuse me, very short. I missed the first slide or two. Are you discussing a product of Nexus's or a joint effort or consortia, or I'm sorry, I missed that.
It's something that we've made. So Nexus made this Orion production interface. In fact, it was John Turner who gave me the idea to call it a production interface. This little guy right here. And so yes, we make them right here, and then program them up with various people helping with the programming. So the idea is it's the Cisco router of the factory floor, but the key part is it now comes standard with MTConnect, and you don't have to be an expert, especially with dprint. It'll translate what you give it into MTConnect, so it does it automatically. And this is the beginning of making it easy for people to get MTConnect coming out of the machine. It changes everything, because now it's simple. And that's the purpose of the talk today, is can we make technology approachable and simple for normal people? And if we do, then they will pull us forward. It'll be like Malcolm Gladwell, tipping point. You know, they'll pull us forward, especially if we can make the box reasonable in cost and easy to mass produce, which it is now. So it's working on all kinds of machines, Fanuc, Gasnac, Mitsubishi, all of them. It's Prototrack, electronics, although electronics has a bit of a weirdness to them with their conversation stuff at the end with null. But anyway, there's there's all kinds of little gotchas in our business, but no customer has one type of controller. Very, very, very few of them have only one type of controller. It is a virtually United Nations on the factory floor, and they're not going to go with the MDC solution if they can't get them all. And that was the key, is that we're going to change, the trajectory of MTConnect adoption by making it the right price, easy to do, and that they get something of use. We just have to bundle it and put it in a package and make it easy to mount. It's got, magnets that hold it on, 2 11-pound full magnets. How simple can you get? It's plug and play with the FANUC. There's 24 volt, 2.2 amps coming in 25. So plug it in and go. Or you can grab power from, wherever you get it. USB 802.11 wireless N, although we can do AC if we want to. So people like Machine Metrics said, we'll order 100 a month. Like all the different people that are in the sector. But it does compete with some existing, if it's embedded DNC, then, the Predator, Spectrums, or cams, et cetera, might be, intrigued with it, but not greatly, because we can just use SMB. We can just, map a drive. Simple. And then all the magic occurs with the machine. But that's part of the overall goal of massively parallel architecture, that the work is being done at the extremities. And that's the key here. Can we process the data? Can we take all the junk and then turn it from data into information? Because then the more machines you have, the more boxes you have, the faster your throughput. The better we're going to do. So it is a bit contrarian, but we've been playing this for a while, and it's perfect for vision systems, or perfect for RFID, or perfect for hard I/O linkages, or perfect for remote control, or motion control, or external pallet systems, or HEVs, or any of the other things. It really is perfect. We've even been asked to put it on cranes. They want to have an MTConnect linked to a crane. So this is actually, we've been quietly working in the background. I think something wonderful can happen if we all keep on pushing. So I encourage you guys to keep going with the projects. It's all going to turn out to make the world a better place. At the end of this presentation, I put get a hold of me if you want to. It's right there. Thank you for your